Okay, welcome to our last lesson of analyzing stats. It's going to be on dynamic analysis. Big, the big thing that we need this lesson for is really the culminating assignment. So it's largely a review of stats, and it's good for the culminating assignment to see to what to do in that section of the report where you have to do a dynamic analysis, which is actually one of the more exciting analysis because we don't really have this restriction of we have to fit a certain amount of data points in that part of the culminating. So we're really just kind of playing around to see really what's going on within the data. Okay, so there's two ways to do this. So I know that outside variables can have an impact on data over time. So we've seen that in the cause and the common cause relationship. I can do an analysis on a data set by identifying and omitting outliers, or by identifying the point in time where a data set is drastically changed. And there could be a hidden variable here, and so we really look at what's happening before and after that point. So quick example we're going to kind of walk through is example 402 from the textbook. We're going to look at, first we're just going to look at outliers. We're going to look at deleting an outlier and seeing what the change is. So originally we look at hours spent studying in marks, and so just to do the analysis, we're saying that the slope is 6.48. So that means for every hour increase in time spent studying, your mark will go up by 6.48%. B is the y-intercept, so it's the mark achieved if no studying is done, 47. And the r-squared is 0.84, saying 84% of the variation in mark is due to the hours spent studying. If we square root the 0.84, we get 0.92, and that tells you have a strong positive correlation because it's in that last third between 0.67 and 1. Very close to 1, so it's almost a perfect correlation. Not quite, but very strong positive. So we take the outlier and we delete the case. So you just right-click on the 30. So right-click right on the 30 and just click delete case. So we've actually seen that there's an outlier by making a residual plot. You can also do that by making a box and whisker plot, and that'll more officially give you the outlier. But you can see the point that's further along the line than any other point. So if we can delete this point here, we can see what happens if that point's gone. So what happens is like the slope goes up to 7.67, the y-intercept goes down to 44, and the correlation does improve a little bit from 0.92 to 0.94. The 84% becomes 89%, and just the fit's a little bit better. Moving the outlier resulted in a 1.2% increase in the slope and a 5% increase in the variation explained. And still a strong correlation, a better correlation than what we had before. Okay. Second way we can do this is a hidden variable. From example on page 411, we're looking at absenteeism for male and female. And so we're going to look at first we're going to look at years versus males and years versus females, the number of absenteeism. And so we've got our slope. It slopes originally are 0.1232 versus negative 0.0994. So what they're saying is males increasing absenteeism, 0.1232 average absences per employee per year, and female is actually decreasing by 0.0994 absences per employee per year. The y-intercepts really are meaningless due to the size of the x variable. We're looking at years. So they really mean nothing. They just give you the shape. The r-squareds are 72% versus only 19% for female. The r value is strong positive when we square root it for males, but it's a moderate negative for females. We note that there are two positive linear relationships in the female graph. So the female graph actually says it's negative, but it's actually looking at two positive relationships over the years. So something changed actually around the year 1996. After we look at, so if we just fit the data after 1997 and over, we actually see like the slopes 0.0969 on average absences per employee per year, and then female absenteeism is increasing by 15. So it's no longer a decreasing slope; it's increasing, and it's increasing faster than the males since 1997. The R squared is only 46% for males since 1997, and 61% for females. The R value is 0.68 for males, so it's kind of strong, still strong positive, but it's on the low end of strong. And female is actually stronger, so the relationship is now stronger. And so we can see like what's happening here. And actually, what is true is before 1996, they counted absentee maternity leave as absences. And so after 1996, that changed. That's a huge, huge impact on the data. And so we can see that in the since 1997 and on, we have a lot stronger model for females. A couple practice questions you can do are in the folder here. Employee productivity data. I put some of the solutions on here. So just removing the outliers from the textbook. Put some of the solutions in here. The hidden variable for productivity, just to look at this, like we've got a number of employees versus annual production, and so like you can read through this. I've kind of analyzed some of the slope, the R squared values. We actually see that if you refit the data after, there is some evidence of a management decision that's coming in. So you can take a look at that data. It's really interesting data to actually play with the hidden variable. You can see that something happened around 2005. So if we fit the data after 2005, so 2006 and on, we can see that the productivity is actually going up. Okay.